Friday except work on work. So those of you that had other obligations, you didn't miss anything. So we're talking imaginary numbers today. Imaginary numbers are a whole other world of numbers. So our number system has two parts. We have the real numbers, and then we have all the imaginary numbers, okay? And that makes up our big, giant, crazy, weird number system, okay? And so today we're talking about the imaginary part. We are learning how to simplify imaginary solutions. First, so the imaginary unit, I, is defined as I equals the square root of -1. So we can't take the square root of negative numbers. Like we can't take the square root of -8. It's imaginary. And if you take your calculator out and you try to do that, it would remind you, say, hey, that ain't cool, yo. So it says non-real answer. It's non-real because it's imaginary. All right, these are our imaginary friends numbers.
Yeah.
Is there?
You just click on mode, and then you go down to real.
Oh.
And then just go right.
Hey, oh my goodness.
Does not show yelled at us for using it.
Oh, interesting. Yeah. That's crazy. You can see that there's a little I there. Of course, this crazy decimal is a crazy number. All right. That's kind of interesting. So interesting. I saw it there when you said that. I was like, oh my God, there is an A plus B I there. That is interesting. Okay. Well, that's kind of cool. This would never be accepted as an answer that we would want in our math classes this way. So I do think that probably want to go back to regular, real numbers there. But certainly maybe you could use it once or twice if you needed to double check something. So that's pretty interesting. Okay, so it's imaginary. However, if it was the cube root of -8, can we do that? What is the cube root of -8? -2. Mm-hmm. So cube roots, and you can try it. You can do under the math menu. You can do the cubed root of -8. So we can take cube roots of negative numbers. Okay, because -2 times -2 times -2 gets us that -8 we're looking for. All right. It's only the even roots where we have to worry about imaginary or I. Okay. So pure imaginary. This is useful in working with square roots of negative numbers. So that's what we're paying attention to today. A pure imaginary number is written in the form of something times I. We just used a B. So B times I, some number, like a 3 times I, or 7 times I, or a -2 times I, where B is the real number, and I is the imaginary part. So we want to write each radical as a pure imaginary number. And I think a good way to break these down is to sort of break them apart here. We can separate one giant radical into a bunch of little babies. So I'm going to break up this radical -144 into a square root of -1, and then the square root of 144. So really I can multiply those together and give me that -144 under one giant radical. I can also undo that. And what is the square root of -1? Just I. And what is the square root of 144? 12. And so we can square up both pieces there and get 12i as our pure imaginary number. A square root of -80, I'm going to break that apart into, let's see, I have a square root of -1. And 80, the easy way to clean that up is 80 happens to be 16 times 5. So I can split that up into the square root of negative 1 times the square root of 16 times the square root of 5. So we're just breaking it apart into our little perfect squares. And what is the square root of negative 1? I. And the square root of 16? 4. And I can't do anything with the square root of 5. It's as clean as can be. And just to write that in a more normal order, I would do 4 root 5 times I. Oh, that's okay. Is there another way? 4I. Yeah. So 4I radical 5 is the best way. This is okay as well, except if you were to get lazy and you didn't end your square root. You see how that can be confusing? Yeah, so that's why we typically would put the I before the radical. We don't want to be confusing. 3. Again, we can split it up as the square root of negative 1, and then the square root of 36 over 121. 6 over 11, yep, the square root of 36 is 6, the square root of 121 is 11, and then we are multiplying by I. It's the square root of negative 1 is I. So 6 11's I would be great. Okay, so powers of I. This is a really common SAT question, which I think is just stupid. Your knowledge of the powers of I does nothing to convey your knowledge of math. Like, sometimes I hate the questions they ask on SAT. But this is a common question. What is I to the 86th power? That's the question. And so how do we get there? Well, we're going to see some. But we know that the I to the first is the square root of negative 1, and we call that just I. Well, I squared would be the square root of negative 1, and we're going to square that. What happens when we square a square root? Yeah, it cancels itself out. And what does it leave behind? Negative 1. All right. Well, I cubed happens to be I squared times I to the first power, right? So since they have the same base, we can add those exponents. All right. So then what's I squared? Negative 1 times I. So negative I is how that would simplify. So I to the fourth power could break apart into what and what? I squared times I squared. And of course, I squared is negative 1. And another I squared would be multiplied by another negative 1. So what will we end up with? Just positive 1. All right, let's continue the pattern. Okay, let's see if it repeats. All right, I to the fifth, I think, is I to the fourth times I. All right, what's I to the fourth? 1. All right, oh, hey, look at that. It's just I again. All right, I to the sixth. I to the 4. Oh, there's lots of ways we could break these apart, which is kind of interesting. I to the fourth times I squared, maybe. We could do it that way. Let's see. So I to the fourth we know is 1. And I squared is negative 1. So we get, hey, negative 1. What can we do for I to the seventh? I to the fourth times I cubed. Yeah. I to the fourth we know is 1. I cubed. Negative I. So that's just negative I. Hey, look at that. It's also matching. Crazy. And I to the eighth. I to the fourth times I to the fourth. Could I do I to the fourth to the second power? Yeah? Okay. And so I to the fourth, we know is 1. And then, of course, if we square that, we still get just 1. Okay, great. So we see this pattern. I, negative 1, negative I, and then positive 1. And, of course, if we were to keep going, I to the 9th, I to the 10th, I to the 11th, I to the 12th, it's always going to repeat. Okay? So let's figure out what we would get for something like number 5. This is I to the 21st. What would be, it has a negative 3 in front. try and clean up that I to the 21st to figure out what its value is. What are we thinking? So what if I put I to the 20th times another I to the 1st? Okay, so I'm going to start there just to break it apart. 20 is a kind of nice thing. So, I understand what you're talking about. So you're thinking, if I did I to the 4th, and I repeat that 5 times, like that, okay? And then times another I. Okay, so here, this would be I to the 20th, because we get to multiply those powers. All right, what is I to the 4th? 1, okay. And so, of course, that's negative 3 times 1 to the 5th, which is 1. All right, times I. So we get negative 3I.
And what was even the point of putting that 21 up there?
So that we learn to simplify. Yeah, that was the point. So that we learn how to clean these up. All right, on number 6 here, I'm going to multiply my numbers together. 6 times 18 is, I have no idea. 6 times 18 is 108. And this is I to what power? I to the 16th. All right. How can I help myself with I to the 16th? I to the 4th? So 108. I to the 4th to what power? To the 4th, yep. Which is just 1, all right? So I to the 4th is 1. To the 4th power is just 1. And so we just get 108. Crazy, huh? All right, really, let me know if you have a question here. Let's do number 8. For all the money in the world, for this first grouping here, all the money in the world that I don't have. So, but what is negative I squared to the 5th power? What does that clean up to become? I don't know. But like, my question is it I to the 10th or is it negative I to the 10th power? Is it I to the 10th or is it negative I to the 10th? Okay, good. It does keep the negative there. Good. That is written out 5 times. We have an odd number of negatives there. So be very, very careful with that. All right, good. All right, and then the second grouping, what's that going to turn into?
Negative 3I to 50.
Nope. Negative 27. Why negative 27? 3 times. Yeah, negative 3 times negative 3 times negative 3. Written out 3 times. So negative 27, and then I to the 30th. Okay, great. So if I were to clean that up, it becomes negative times negative is going to give me positive 27I to the 40th. And of course, 40, that's a pretty easy multiple of 4, right? All right, and so if you're thinking long about it, I'd say it's I to the 4th copied 10 times. But of course, I to the 4th is just 1. So what's our answer? 27. Yes. That's what you meant, right? Yeah. All right. Good. On number 9. Yeah? Are we there? Yeah? Okay. Number 9. What do you suppose we need to do with this radical and the negative underneath? Simplify it first. We have to simplify that first. What escapes from this radical? A 3i. and then that's being cubed. And then that's going to be times 2i to the 6th power. All right, so we got to simplify those radicals first, absolutely. All right, let's, what do we get 3i quantity cubed? 27i cubed, good. And then 2i to the 6th. 2 to the 6th is 64. I to the 6th. Okay. All right, so 27 times 64, I have no idea. 27 times 64 gives me 1728. 1728, and this is I to the 9th. I to the 9th. What is that going to simplify as? I to the 8th times another I. Yeah, so I to the 8th we know is 1, and another I is just going to be I. So 1728I. Okay, do you have questions for me right now? Is that okay? Yeah? Okay. Okay, so now the easy part. The thing we really want to remember here is I squared is negative 1. This is a beauty right there. I squared is equal to negative 1. And that's something that's going to come into play here when we are working with complex numbers. So a complex number is written as a plus bi, where a represents the real portion and bi represents that pure imaginary number we were just talking about. And the nice thing is we know how to do this. It's very easy. We just have to add, subtract, and multiply. We're good. So let's look at number 11 here. We are basically simplifying. We are basically combining like terms here. What do you want to do with the negative? Distribute it is the easy thing. So negative 3 plus 5i. I'm going to distribute my negative, so it becomes negative 4 minus 6i. And then I can just combine parts. So a negative 3 and a negative 4 give me negative 7. And then I have my 5i minus 6i's gives me negative 1i, or just negative I. All right, that was easy. Number 12, we're going to go ahead and distribute that 4i. So 4i times negative 8 is negative 32i. And then 4i times 5i is going to become 20i squared. 20i squared. But what is that I squared? Negative 1. So it's really 20 times negative 1. So anytime you have that I squared, you got to make sure you clean it up. So this becomes negative 32i, and then 20 times negative 1 becomes negative 20. Is this an okay form to leave it in? Yeah, it's fine. Is it in a standard complex number form? No. Negative 20 minus 32i is also acceptable. Either one of those is totally fine. So. All right. What do we want to do on 13? Distribute. Very easy. Let's see. 6 times 3 is 18 plus 12i. And then negative I times 5. Negative 5i and positive 7i squared. And what do we need to notice there? I squared. Yeah, makes it a negative 7. And you can do that in your head if you want to. But I don't like making mistakes, so I just write it out and fix it. All right, so I have 18, 12 i's minus 5 i's is 7 i's, and that becomes a minus 7. 7 times negative 1 gives you that negative 7. So I'm at 11 plus 7i. Good? Question so far? It's easy, right? This is the easy part. Yeah. Okay. Great. What do we need to do on 14 and 15? Foil. Do I need to do it?
No.
No. Good. What do we need to do on number 16? Write it out. 3 minus 11i times 3 minus 11i. And then foil. Okay, great. We are going to do 17. All right, what do we have to do first on 17? FOIL. We've got two bubbles we need to multiply together. We also are going to distribute the 3. So let's see. First times first is going to give me 42. The outside gives me negative 7i. The inside gives me negative 12i. And last times last is positive 2i squared. Very good. And when I distribute the 3, I'm going to get positive 9 times 3 is 27 minus 15i. All right, what do we need to clean up? We got an I squared on there, so that's a negative 1. All right, so that becomes, let's see, I have to combine some like terms here, don't I? So you know what I'm going to do? I'm just going to like change that. It becomes a negative 2. I'm just going to write it like that. Can I do that? All right. All right, let's see here. I've got, gentlemen, what are we getting? Since you're talking, you must be done. 67? 69? Oh, no. Oh, and then the minus 2. You're right. 67. Okay, good. What's up? Did I make a mistake? Yeah. Okay. All right. I forgot my. Oh. Okay. All right. And then we have the negative 7i, negative 12i, and negative 15i, which gives me negative 34i. Okay. Negative 34i. Okay, very, very good. Okay, dividing. So remember, this I is the square root of negative 1. So right now on 18 through 21, we have a square root, a radical in a denominator. We cannot have radicals in the denominator, so we must rationalize. All right, we must rationalize to get rid of that square root. Just like if we had 8 over square root of 3, we had to multiply top and bottom by the square root of 3, and that was going to clean it up for us. So here, I have that I in the denominator. What can I multiply by to clean it up nicely? Square root of negative 1, or just multiply by I, top and bottom. All right. So I'm allowed to multiply by top and bottom. That's going to give me 6i over 7i squared. And of course, I squared is negative 1. So we really just get 6i over negative 7. So yeah, we can pop a negative 6/7i. Okay. Number 19. What do you suppose we need to multiply by? Yeah, so same thing. I really just need to multiply top and bottom by I to clean that up. And of course, that means what are we going to have to do in the numerator here? Distribute that. Yeah, distribute the I. So it becomes 26i plus 4i squared over 8i squared. And of course, we've got those I squareds in there, so I'm going to clean those up. So this becomes, let's see, 4 times the negative 1 becomes negative 4 plus 26i over negative 8. That's not an awesome answer. It looks weird, right? Right. So what I'm going to do to make sure that you always do this correctly, this negative 8 is dividing both terms. It becomes negative 4 over negative 8 plus 26i over negative 8. By splitting it up, you're always going to reduce it correctly. Okay? What is negative 4 over negative 8? 1/2. And 26 over negative 8, the 26 over 8 just reduces to 13 over 4. And positive divided by negative is negative. So 13 over 4i. So 1/2 minus 13 over 4i is a great answer. And you'll always do it correctly, which is why I do it that way. Okay. So 20 and 21 are a little bit different. What do you notice about those? So if I just multiply by I, is that going to clean up my denominator? No, it doesn't. So we have to do something a little bit different on these two because they are binomials on the bottom. We must multiply by the conjugate. All right, so just like with radicals, we have to multiply top and bottom by the conjugate of this denominator. So what is the conjugate? 2 plus 6i. Very good, on top and bottom. And then you can clean it up from there. I think I just want to do I want to do that one? I just want to do one of these. I just want to do 21. So on 21, what are we going to multiply top and bottom by?
1 plus 3.
Yeah, 1 plus 3i on top and bottom. All right, so what do we have to do with both of these? Distribute FOIL. FOIL on top and FOIL on bottom. Okay, so I have negative 5 times 1 is negative 5. The outside becomes negative 15i. The inside becomes 5i. And last times last becomes 15i squared. Can I just go negative 15? And I'll write it in red so we know we did one more step there. All right. On the denominator, I have something very interesting happens when we FOIL this out, and this is a good thing to know. Let's see, first times first, 1 times 1 is 1. The outside is positive 3i. The inside is negative 3i. And then again, last times last, negative 9i squared becomes positive 9. What happens with the positive 3i and negative 3i? That cancels out. And that's what multiplying by the conjugate does for us. It gets rid of that I term we didn't want. All right? And so that cleans up super nice. And so we have, let's see, negative 5 and a negative 15 is a negative 20. Negative 15i plus 5i is negative 10i over 10. And that can totally reduce. Again, you can split that 10. It's dividing both pieces. Hopefully you can see what that cleans up to on your own easily there. But 20 divided by, negative 20 divided by 10 is negative 2 minus I. Since those 10s will just cancel out there. All right. I like it when they clean up like that. It's just kind of nice. Okay. Questions on those? All right. Just a couple more. We are almost done here. Operations with negative radicals. Again, negative square roots are a huge problem. So you must simplify the root first using I, and then we go from there. Otherwise, we get really weird things. Okay. Although maybe now that you have that real thing, your calculator can handle it. I don't know. So the problem is, yeah, like you can try it here. In the mode, I'm going to switch to a plus bi. But if we type in the square root of negative 15 times the square root of negative 5, we get this. But this is really negative 5 root 3. Negative 5 radical 3. There you go. So the question is, you're not going to be given a decimal. What's the exact answer? All right, so this is a crazy approximation. this is the exact answer. So your calculator is still not going to give you that exact answer that we're really looking for. Let's do number 25. First, I need to clean up these radicals. The square root of -6 simplifies as what? So we have the square root of -1 times the square root of 6. Yeah, so just that square root of -1 comes out, the I comes out, that's all. So we have -4i radical 6 times 7 minus 3 root 12. So I had to clean up my negatives first. And now we can do what? Distribute. So -4i radical 6 times 7 becomes what? The hiccups are catching. -28, yeah. We can multiply the number, regular old number things together. So that becomes -28i root 6. And then when we distribute it to the -3 root 12, what do we get? So 6 times 12 is radical 72, yeah. And so we can multiply the radical things under a radical that way. All right, 72, root 72 is 30, thank you, 36 times 2. That is such a good one there. So that, we can take the square root of 36, what comes out? Yeah, that 6 gets to come out and multiply with the 12 in the front of that. So we have, yeah, so -28i root 6 plus 12 times 6 becomes 72i root 2. And that is all we can do. So I can't break down the 6 and clean that up. So this is the final answer here. It doesn't simplify any further. All right, let's do one more here. Just last one. Oh, what do we need to do here? Yeah, we would, but first we need to clean up our negative inside the radical. What can come out? I can come out. So we get -4i root 2 plus 1. And that we need to write out 2 times. So -4i root 2 plus 1. So got to clean up those negatives, clean up those radicals first, and then go from there. And now we're going to FOIL. All right, so first times first becomes squared radical 4. You can absolutely do that. Radical 2 times radical 2 is radical 4. That is also going to clean up. It will, yeah, that will clean up. So both of these are gonna clean up, and I'll just do that in the next step. You're right. And then the outside becomes -4i root 2. The inside is again -4i root 2, and last times last is 1. So the square root of 4 is 2. So 16 times 2 is 32. And what's I squared? -1. So it becomes -32. And then I have -4i radical 2, -4i radical 2. That's -8i's radical 2. Plus 1. And then the -32 plus 1 is -31. Minus 8i root 2. Yes, sir. Yeah, thank you for waiting. Okie dokie. Any questions? All right, ladies and gentlemen, that's it. Woo! Wow. All right. Super. 35. That was long, but not terrible.